this computer. Okay, so if you want to open up the microscope software, it is XM Dashboard that's right here. If you need XM Flex, it is the one right underneath it. I'm not sure what this is, so we're going to ignore that. That does not look like it's the proper XM Flex. So we'll open up the Data Explorer. Once it's open, the first thing you want to do is go to the drop-down menu, but with the magnifying glass, and change it to 10x. Neither objective is selected, so it needs to have an objective selected. You also probably want to start the condenser agitator, so you can click that button, and if you see this sine wave, you know that the agitator is running. The last thing I like to do at the very beginning is also open the Python and open up XM Flex, just so we have that already opened. So we click on the Python window that allows both the Python and the microscope's Data Explorer software to both control the motors, and then we can actually open up XM Flex. And so we can go back to the dashboard, minimize this Python console, and then we will explain all of the icons. I think that's easiest. So this obviously is to open files, save files. We've already clicked on the Python. The gears, if you remember, is to have different acquisition settings. So often when you're finding your sample, as long as your sample is not radiation sensitive, you want to do continuous mode. That's just like a video camera. You can also do single shot, just take a single image.
Yeah.
Mosaics to find your sample if you just want to look at a region of interest. I often do that when I've got when I'm picking out different regions. Andre's sample may be good for that if you wanted to find two different regions.
Okay.
Tomography, we don't use that much. Average we'll do for doing reference corrections. And then the focal series does a set of images while moving the Z motor through the focus. So that's good for finding the focus of your sample. It's best to start with a large range. You can decide the range. Sorry, this is still an averaging focus. There we go. You make sure that it's sample Z and you can choose the range. I would choose a large range, like 5,000. If you're far from the focus, and then decrease that range as you get closer and closer. 11 projections is kind of nice. 11, 7, something like that is a good amount of projections. Background we'll never use.
Okay.
Okay.
So for the continuous mode, like that, we shouldn't use that, for example, with the D-bands, the carbon stuff.
It will be a good way to test the radiation sensitivity of the D-band. If
Okay.
we see morphology changes using continuous mode, we know we need to be careful. If we don't see any changes, it's probably not going to be a big deal at all.
Okay.
You can always do continuous focus, find some spots. I mean, just find the focus and then go to a fresh spot that's at least like 100, 200 microns away.
Yeah.
And reduce the damage to that spot.
Gotcha.
You shouldn't have a real change in focus if it's just that small distance, but you should be far enough away that the radiation doesn't matter.
Okay.
So typically when we're just looking for a sample, half a second is a good exposure time, and we do a binning of 2. We don't usually change anything else. The pixel size should match your energy. I have an Excel file on that, and I can change that once we get the zone plate positions correct. And then this is where you apply your reference. So you can either have no reference, or you can find your reference and apply it. So if you're going to collect a reference, you go to average, And usually we do 10 projections. You probably want half a second exposure. It depends on the energy. Sometimes 1 second is good, as long as you're not saturating the detector. Definitely a binning of 2. And then you want to make sure that there's no reference applied. And then you just collect the references. Oh, and you want to make sure that there's averaging on the fly.
Okay.
Mosaic, the thing about Mosaic, this top part is all the same. You can do multiple images per projection. We hardly ever do that. Actually, I would say we never do that, and we never put a weight in there. And then the horizontal and vertical steps are auto supplied with the assumption that this pixel size is correct. So this is the one field of view. You can change that sometimes, like if I'm trying to find an area and I'm too lazy to do continuous and just move around. I do like 100 or 200 step sizes, knowing that I'm obviously not taking a continuous image, but it's easy to find things then, like a hole in your sample plate or something like that.
Yep.
And then your rows and columns is another thing you'd change. If you're going to do 10 by 10, this is too large for binning 2, so you'd have to go to binning 4. If you go to binning 4, your exposure time now probably is too long, because now it's the equivalent of a binning 2 1 second exposure. No, 2 second exposure, sorry. Because it's multiplied by 4, so you probably want to do at least a quarter second. Maybe smaller, but a quarter second should be good enough. I don't think you'll saturate then. If you want to stick to binning 2 for a mosaic, the largest mosaic you can safely do is a 7 by 7, about a 50 tiles.
Okay.
You can obviously do 5 by 10 too, or something like that. It's just the total number of tiles that matters. You also don't want to have multiple mosaics open at once.
All right.
Okay, so that's the biggest things on this acquisition settings, or the gears. If you ever lose this window, you can always just click it again, and it'll pop it up to the top of the pile of windows. Then whatever settings you've done for continuous and single mode are used in these 2 buttons, where this is a single shot. Obviously we don't have x-rays right now, so it's going to be dark. And then this is a video camera, so it's continuous imaging. So those are nice shortcuts. I use the stop button. Obviously it stops the imaging. This all motors stop actually stops all the motors plus the imaging. This x-rays off is just ignore it, because that's residual from this being connected to a lab-based x-ray machine. So we don't know anything about the x-rays. And then the final thing is the joystick, which is motion control. All of the different motors are tabs. The motor you'll use most often is the sample motor. You can either type in a amount that you want to move by, like 50 microns, and hit positive to go in the positive direction, negative to go in the negative direction. You can see this is changing. Or if you have a specific location you want to go to, for example, I want to go to 10,000, you can just type that in and it'll go to 10,000. If you have an image, a still image up, you can right click on your image and it gives you lots of options. One of those options is go to position, and it will go to the position that you clicked on. So it'll go back to this, wherever that position was, that image was collected. So if you hit go, you'll go back to that. So it's just moving X. If you want to, for example, do that, but you don't want to go exactly to that position, for example, you know that this is the wrong focal length, focal position, so but 5,000 is correct, you can type in the position you want. Or for example, you want to go to 10 degrees, you can type that in and then hit go. And so now it's moving to 10 degrees and it's moving to a different focus spot.
Okay.
I'll go back to 0. The house button homes all the motors. If you accidentally click it, it will ask you, do you really want to home? Click no. You don't want a home. The 0 button sets things to 0, but it also displays user offsets, so it's not really set to 0. You can just unclick that and it goes back to the normal numbers. You can see when it's user offsets, they're yellow. Actual numbers are white. We don't tend to use user offsets anymore.
Okay.
Other things, if you want to move the sample and you're doing continuous imaging, instead of right clicking, which you can still do, you can also double click anywhere. It's obviously not going to be very interesting, but if you double click and you could see on, for example, the motion control that it actually moves X and Y. You can see that. And so that's a good way to move around your sample as you're looking at your sample. Obviously,
Okay.
really boring right now. Hit stop. Close that window. There's another stop all motors button here. There's lots of them. Other motors that you may move, the pinhole. Sometimes when you have a bright spot somewhere, just a single bright spot on your field of view, it might be the pinhole that you maybe bumped a little bit. You can move 2 microns in X or Y, plus or minus. I would just put continuous imaging on and do that, and see if the bright spot gets worse or goes away. Try to go in the direction that it goes away.
Okay.
I wouldn't move more than like 2 microns in any direction for X and Y.
What's the lower limit on how far you can move? Like how many, like 0.1 micron or?
Oh, our motors aren't that good, so none of the motors move reliably below a micron.
Okay.
It's a 40 micron pinhole, so 2 microns will be probably just the perfect amount. It might be a little too little. So it might be that like the bright spot dims but doesn't completely go away. So go another 2 microns.
Okay.
And it might be a combination of X and Y as well.
Yeah.
If you bump the pinhole a lot, it'll just be dark. And then you just call me in. The phase rings no longer connected. There's no motors. The condenser, you'll never move that. Tube lens will likely never move as well. The zone plate you may move. You can manually move the zone plate positions. When you move an energy manually in spec, you want to put down the zone plate positions, X, Y, and Z. Z will be moving the most, and then X and Y are just sort of to keep the beam centered on the zone plate. And you could either write down those positions as we get them, or we'll have an image saved for every energy you want, and you can open that image up, click on this little arrow to go to the metadata. And then in the metadata, there's this tab called positions. You click on that, and this is a lot of the same numbers. If you look, they're actually all the same numbers. So it's not as complicated as it looks. So pick whatever column you want, and you can read off the zone plate X, Y, and Z positions and type those in. Remember to type them into this box and hit go, and then it'll go to that position.
Okay.
If you're using XMFlex to actually take the data, it will automatically calculate those and implement that on its own.
All right.
That's all the motors. So the motors that you'll use are sample, sometimes zone plate, and only if you bump it, the pinhole. Any other motor, if you're going to move it, ask me first.
Okay.
But you should never have to move it. I think that is the main thing. Obviously, one last thing, if you're taking an image, down here, there's a histogram. You can do all the fun things with histogram. You can look at the full range, auto scaled. You can custom scale by dragging the mouse, the left click and drag. You can also go log if you want. Anyways, I think that's it. So I'm going to hit stop recording